So hope everybody is doing fine. And this time, mostly uh, we'll do our most of our exercise on online mode. But if system or the institute allows us to go for offline, then we'll switch over to offline mode. At least as per Dean's directive, we'll continue the stitching process on online mode till 31st of January, and after evaluating the situation after 31st of January, we'll decide whether we'll go for online or offline mode. Now, in this particular course, we need active participation from students because if you see, the courses will discuss their different contents are not very different from the basic chemistry you already learned in your class 12 or maybe in first year chemistry courses. It will not be very different from that. So because the course is talking about bioprocess technology, that means we'll discuss about different technology we use to produce different bioproducts, which is not very different from chemical products. Because if you remember in your class 2 or maybe before that even, you have learned about different process technology to produce different chemical compounds like sulfuric acid, hydrochloric acid, um, baking soda. So different kind of chemical compounds when you need to produce industrially, then you need to have a process flow scheme to get your desired product produced at a larger scale. So you can actually use your knowledge in science and then try to synthesize these chemicals in laboratory in small scale system. But when you try to produce them in industry scale level, then you have to just scale up the process, and then you have to check the economy of the process to get economically suitable process to produce the desired product. Like if you need to produce hydrochloric acid or sulfuric acid, you can do small scale operation, like you can take 100 ml beaker or 200 ml conical flask, and using laboratory stirrer you can do the reaction and then produce maybe 50 ml or 100 ml sulfuric acid. But when you need to produce a huge amount, say we are talking about 1 ton or maybe 2 ton per day, then definitely use of this small volume system will not work. And it is not possible for you to actually have thousands of small reactor system or small conical flask to get that high volume. So in this particular course, we will actually discuss about different bioproducts, and also we'll discuss about the procedure to produce those bioproducts at larger scale. So larger scale is actually depends on the requirement of the product. So market requirement could be, say, in kilogram per day or maybe kiloliters per day. There we'll talk about reactor system which can manage that kind of production capacity. In some cases, you may require to produce different kind of material in tons. Tons means or maybe 10,000 liter or 1 lakh liter per day. So even few systems are there where the capacity of the system would be in 10 lakh liter per day, means like 1 million liter per day or 2 million liter per day. So that kind of capacity we may require for specific bioproducts. So whenever we'll discuss about different bioproducts, then you can actually see the kind of requirement they have in the present market. Suppose we are talking about production of one pharmaceutical compounds, and that compound could be an antibiotic, could be some enzyme, could be some ingredients for vaccine preparation. So depending upon the requirement, we need to set up the plant, and then we need to actually check options for different processing unit to produce desired compound at desired level. So this course is actually a 2 credit course, and as I mentioned that initial few classes will discuss the basics of bioprocesses like flow diagram or how to define a bioprocess, and then we'll try to understand the key component present in any bioprocesses, because you can actually generalize any chemical or bioprocesses based on some key requirements. So we'll discuss that also, and then finally we'll also discuss the techno-economical feasibility, because whenever you have multiple options to produce a specific bioproduct, you need to check which particular process path will actually give you better profitability. So energy usage, means efficient material usage, these are all quite important factor when you talk about development of a profitable bioprocess. And while discussing about different bioprocesses, I'll just give you few examples. Then I'll require your active participation for discussing different bioprocesses in the class, where a group of students will present the details of bioprocesses and other students will actually listen to them, and finally we'll ask some questions from those discussions. So a few bioprocesses I'll discuss, and then also I'll request your participation to discuss two other bioprocesses in the class. And finally, whenever we'll set the question paper, that time we'll actually ask question from all the processes we'll discuss in the classes. So I'll give you some example, so you'll actually have some idea how to discuss and what kind of key parameters should be discussed while presenting a specific bioprocess. And then different groups will present individual bioprocesses which will be little different from the bioprocess I'll discuss. And then based on the class participation as well as discussion, we'll just set question paper. And most of the cases when you need to answer the questions, mostly you will face either MCQ type or fill in the blanks type question papers. So in course evaluation policy, we'll have one minor, one major of 30 marks each. And then in class participation, we'll have 40 marks. So class participation means the group wise, you'll be assigned to present a specific bioprocess, and based on the performance of individual member of the group, we'll evaluate and then we'll score them out of 40. So each group,
Sir,
it's to, yes.
sir, are you writing something on the whiteboard? Because we are.
So it is not responding. Just a second.
Yes, sir, we can't see anything. Like the whiteboard is blank for us.
We can just see a S mark there and nothing else.
Oh. Okay, so we'll have, oh, it has some problem. We'll have 30 marks for minor, and for major we'll have another 30 marks, and for class participation, that's really or it is actually, you can say, oh, I'm not talking about attendance, because if you don't attend regularly, you will be missing some classes, and if you miss the classes and don't pay attention to the lectures, then you will have trouble to solve the problem we'll discuss in the exam. So it is not exactly class participation, it is actually, you can say, the oral presentation or assignment. There you will get 40 marks. So we'll create the group, and then I'll circulate the group information using the course mailing list. So you can see the group members, and this particular exercise will start after discussing few bioprocesses in the classes. Then only you can get reasonably good idea how to explain a specific bioprocess considering different aspects. And when we talk about bioprocesses, we'll actually discuss about few key production process. So generally, production of any biological material or bioprocess system can be classified in 5 broader groups based on their nature of the product. So we are talking about 5 different types. One is when your target is to produce more biomass. So one option is to produce more biomass or microbial cell. Second option is to produce enzymes. That could be intracellular, extracellular. So enzymes, again, these are all microbial products. So I'm not going to write microbial everywhere, but it is, when we are talking about enzymes, it is actually microbial enzymes. So that enzyme could be extracellular or intercellular. Then we can have different metabolites like antibiotic. Then we can have a different recombinant product. Like if you use a recombinant organism, then you can produce different bioproduct using the recombinant organism. And then finally, you can get biotransformation. So you can use biological mix to transform one biological substance to another biological substance, like production of vinegar. So you can convert ethanol to vinegar using biotransformation. So these are called transformation product. So broadly, we can get these 5 different types of bioproduct, and based on the requirement, we can just classify them. Like if you need to produce a lot of biomass, then the bioprocess will actually have a target to produce a lot of biomass, where most of the substrate or most of the raw material you will try to provide to the system in such a way that the biomass or microbial cell will try to utilize this nutrients or substrate to increase their cell number. Instead of producing any other secondary product, they will just try to increase their cell number. Whereas in other cases, if you need to go for any extracellular enzyme production, then you will make sure the reaction moves in such a way that you will get more production of this extracellular enzyme. Similarly, if you get metabolites, there also you will try to channel your reaction strategy in such a way that biomass should produce more metabolites than the other compounds. And obviously in all production process, whatever other components will get synthesized or produced, mostly they will act as impurities. So when you try to define impurities, it is all other compounds present in the system than your target compounds are called impurities. That impurities could be more valuable, that impurities may have some other secondary use, but when you try to define impurities, it has a different perspective. So you have your key product. So apart from your key product, whatever components are present in the system, they are all impurities. So if you get more impurities, then purification step will be more cumbersome. So whenever you select a specific bioprocess scheme, you have to make sure you choose a specific reaction where you get less impurities, you get higher concentration of your desired product, and also this process will be more energy efficient. So then you can get higher profitability. So when you discuss about this bioprocesses, we'll actually give example of each type of bioprocesses. And whenever you need to present any specific bioprocesses, you can actually just, that will also fall within this categories, one of these categories. Anybody has any confusion or any difficulty in understanding?
No, sir.
So can you
Okay.
talk about which kinds of metabolites will be we will learn to produce?
Yeah, so metabolites, we can actually discuss about different antibiotics, and there we'll discuss about different broad spectrum and narrow spectrum antibiotics, and also other products like bioplastic. So when you talk about metabolites, the components which are produced during the metabolic activities of the organism, and they may or may not directly get utilized for biomass formation. Those metabolites can be purified using specific method, and then you use them for their specific usage. Like few metabolites may be used as one of the active ingredients of another secondary process. Like if you just give you one example of penicillin. Suppose we are talking about penicillin. Penicillin is one of the uh, you can say in terms of secondary metabolite production, it is one of the most exploited product, and many industry they produce penicillin, that is the active ingredient for the final antibiotic. Now when you use penicillin, it is very much possible the penicillin may not be very effective to treat a specific pathogens or specific disease, because many bacteria, they already acquire resistance to defend penicillin. So in such cases, we also add some other biosimilar product which will look like this antibiotic, but they will actually inhibit the inhibitory enzyme secreted by antibiotic resistant bacteria. So suppose the bacteria you're trying to treat is say Salmonella now or E. coli. Now that E. coli is synthesizing certain chemicals which can degrade the penicillin. So if the enzyme produced by the bacteria is efficient enough to degrade the penicillin, then we will not see good effectiveness of penicillin to kill the bacteria, because bacteria will secrete certain enzyme which will react with penicillin. So penicillin will not get sufficient chance to interact with the cell biomass, and you will not have reduction of biomass, because the penicillin kind of antibiotic actually interact with the NAG and NAM present in the cell wall of the bacteria. Now, this antibiotic is actually has a mechanism to create problem with the cell wall stability. So whenever it will interact with the cell wall, it will actually break the cell wall and it will kill the bacteria. Now, if enzymes secreted by bacteria can inhibit penicillin, then penicillin will not be effective to kill the bacteria, and it will not be able to treat the disease. But if you use another biosimilar product which will mimic behavior like penicillin, but it doesn't interact or doesn't react like penicillin, in that case, the enzyme will think that the other biosimilar product is present and that is also look like penicillin. So enzyme will actually get engaged with the other biosimilar product to neutralize the other biosimilar product, while penicillin will get sufficient opportunity to interact with the biomass and then it will kill the bacteria. So most of the cases, wherever such issues are there, we use different kind of biosimilar product and then we combine the antibiotic with the biosimilar product. So one of the common example is Augmentin. It's a trade name, but generic name is actually you have two different compound. One is say amoxicillin, which is actually a penicillin group of antibiotic, and or say beta-lactam group of antibiotic, and clovulanic acid is another biosimilar product which actually help to interact with the enzyme secreted by this antibiotic resistance bacteria. So the resistant bacteria, whatever enzyme they will secrete, that will get used up to interact with the clovulanic acid, and amoxicillin will get sufficient opportunity to interact with the biomass or that NAGNAM of the cell, and then it will just kill the bacteria. So in one of the process, when you try to produce metabolites, you may produce amoxicillin, penicillin, and then derive it and use it with the help of chemical derivation. You can just produce different derivatives of amoxicillin or different derivative of penicillin. And in another process, you can produce clavulanic acid. And finally, in the bioprocess system, you can just have a mixing tank where you try to get desired ratio of penicillin and clavulanic acid to produce your final formulation. So in pharmaceutical industry, you can have industry where they do only formulation, so they don't produce any active ingredients. So here your active ingredients is penicillin. Other compound is your additive is clavulanic acid. So you can find pharmaceutical industry which are actually making only active ingredients, like they are called as mostly they are known as API manufacturer, active pharmaceutical ingredients manufacturer. And also you can get some company where they just do formulation. So they just buy the active pharmaceutical ingredients from a specific manufacturer and they formulate the final medicine, and then they prepare the packaging of the medicine and they sell the final medicine to the market. So in the metabolites production system, you can have involvement of different API manufacturer, and few API manufacturers, they also have their own formulation unit. So you can actually have a complete process to get the final product or sellable product. So when we'll discuss about this metabolite, we'll actually discuss in detail kind of system you require to produce this. And when
Yes,
you
sir.
use recombinant, yeah, please go ahead.
I was just asking the name of which acid is used with amoxicillin. I did not hear this clearly. Can you write that name?
Okay. So clavulanic acid, but it is not only one acid. So you can get, actually I just gave an example, but you can get different kind of acids. So if you search augmentin, you will get different kind of formulation. So augmentin is actually amoxicillin plus clavulanic acid. So it is one kind of generic name. Better to write a generic name, but just as I remember the name of this machine, particular medicine, but you can get different other formulation. Name would be different. The commercial name will be different, but they will have similar kind of ingredients. So amoxicillin is your antibiotic. And then you can get the clavulanate or this clavulanic acid. Clavulanic, clavulanic acid. So different other biosimilar compound could be there to get this kind of formulation. So this is a common tactics to actually just encounter antibiotic resistance problem. So it is one of the strategy to actually use a different kind of biosimilar product. So it is CLAVULANIC, clavulanic acid, which can be added to the amoxicillin antibiotic. Most of the cases you will get say 500 mg amoxicillin and maybe 125 or 150 mg clavulanic acid. So then you can get 650 total dose. And different commercial name would be available. So augmentin is one of the name. Maybe it is produced by one particular company. Similarly, you can get different commercial name, but they will have similar kind of composition, amoxicillin and clavulanic acid. Now, if you talk about the first example, the first process that is called biomass or microbial cell, it has a substantial market. Means one of the most common example is actually your yeast production. So in bakery industry, they use yeast. Similarly, in other pharmaceutical industry also, they use variety of yeast as their host organism to produce different recombinant product also. E. coli is one of the common organism as host where you talk about recombinant product. Similarly, yeast is also Saccharomyces cerevisiae is also one of the common host to produce different recombinant product. Similarly, Saccharomyces cerevisiae or Saccharomyces cerevisiae, this yeast is also widely used for bread making or say a different bakery product manufacturing is done using yeast. So baker's yeast is one of the common yeast you use in this bioprocess. And when you talk about capacity, some industry may have capacity to produce 10 ton of yeast per day. So in this process, our main goal would be to produce more amount of biomass than any other metabolites. So when you talk about any bioprocess, any bioreaction, suppose you have substrate, then you have your other component, like if you need to produce oxygen, or if you have anaerobic condition, maybe you will not produce any. So for aerobic, will provide oxygen. If it is anaerobic, you will not provide any. So for anaerobic, it is direct substrate to your product with the help of biomass. And for aerobic, you have substrate, oxygen, and then you get the product. So it is your anaerobic process. Now, in the substrate component, you can have carbon, you can have nitrogen, you can have phosphorus, you can have different other trace metals, you can have different vitamins, and then depending on your requirement, you can either have oxygen for aerobic, or you may have anaerobic environment to produce your final product. So in final product, you will get biomass. Here also you are giving certain amount of biomass. So rather we can put it in the left hand side also, some amount of biomass. And then finally you get biomass, some bioproduct, water. For aerobic, you can get carbon dioxide. For anaerobic, you can get methane or many other gaseous compound based on your requirement. Now, this CNP, their requirement you need to calculate, and for that, and similarly for trace element vitamins, you need to calculate their amount to know how much raw material required to produce certain amount of product. So if you get a stoichiometric equation, suppose yeah.
I had a question. Like, how do we produce? How does the methane is produced in anaerobic equation? Like anaerobic respiration. Sir, I don't know like about that yet.
Okay, we'll discuss. We'll discuss in detail. Yes, we'll have also a process where we'll see the anaerobic metabolism. So we'll show you how we are getting methane production, how we are getting this carbon dioxide production in aerobic. Even in anaerobic system also we can get little bit of carbon dioxide because some oxygen present in the substrate or will also get utilized. And if you have minute oxygen present in the environment, that will also get utilized by different organism, and then they produce certain amount of carbon dioxide. So we'll show you. But just I'm giving a broader perspective of the bioreaction system. Then definitely when we'll discuss about individual process, we'll actually show you how we are getting different kind of components. Now I'm just trying to tell you the importance of the stoichiometric equation. So when you try to produce any product, forget about bioproduct. Even if you talk about chemical product, suppose you have A plus B is giving you C plus D. And this D is your desired product and C is actually your undesired product. Whereas D is your desired product. Now, we all know about law-of principle. So it is very much possible that using that principle, suppose you are using a specific temperature and specific pressure to do this particular reaction. Now, to move the forward reaction. So conversion of A to B to C and D, you will maintain high A or high B in the system. So you will get forward shift of the reaction. So equilibrium, you can actually play with the equilibrium condition by manipulating the reaction situation or reaction conditions in the system. Now, if you realize that increased concentration of A is actually producing, or maybe increased concentration of A producing little bit higher amount of C, or increased temperature is favoring higher production of C, then you have to make sure that those conditions should not be followed in your reaction scheme, because higher amount of C production will essentially reduce the yield of desired product. So we are talking about different kind of terminologies. So one of the terminology I just mentioned, that is called yield. So do you know what is the meaning of yield? Any idea?
Yes, sir. Yield is something like according to products being formed experimentally, and the products should be formed according to our calculation. When we divide, then we get the yield.
Not exactly. Not exactly. That is actually you're talking about um, percentage recovery. So theoretical and experimental values can be compared, and then you can get the maximum possible production. So when you talk about yield, yield is actually is very simple terminology where you just take ratio of product divided by reactant. So here our desired product is D, and if you try to compare the yield of D from A, then you can just get either weight. So this product, either you can use weight value or you can use mole value, that is more fundamental. So weight by weight or mole by mole, that can give you yield of D from A. Similarly, you can calculate yield of D from B also, again by taking similar kind of units, either weight by weight or mole by mole. So although suppose I am taking weight by weight, then it will come gram per gram. So this gram by gram should be cancelled out, but this gram is different. We are talking about gram of, say, gram of D, and here it is gram of B. So when you try to express yield, you just estimate the ratio, and then as unit you just mention gram of D by gram of B. So if you get more production of C, obviously yield of D will get reduced, and that is not desired. So you try to maintain specific condition which will favor you to get more amount of D. So you try to get higher yield of D. So that is one of the primary criteria. Now, we have also mentioned that this stoichiometric equation also has significant impact. So if I know that A plus B is giving C plus D, and we know that 1 mole of A plus 1 mole of B is giving 1 mole of C and 1 mole of D, then you can just, instead of putting arrow, you can just equate. That means as per the conservation of mass, whatever amount of A and B you are using, from there you get equivalent amount of C and D. So if you find the balance equation, then it will very easy for you to calculate amount of A and B required to produce 1 mole of B. Like we know about photosynthesis. Okay. Now C6H12O6 plus oxygen will give you CO2 plus H2O. And generally, when you try to balance the equation, you get this will give you the balance equation. So if you know the balanced stoichiometric equation, then actually you can calculate how much amount of glucose you require to produce 6 mole of carbon dioxide. Here in the chemical reaction system, it is easy because you know the chemical formula of the compounds and then you just equate them to get idea about the concentration of product or substrate. So if you get the balance equation, it is very easy for you to calculate individual component required to produce certain amount of product. Whereas the equation I have written here, I have mentioned about carbon, that is one substrate where you will have carbon, another substrate where you will have nitrogen, another substrate where you can have phosphorus. Some substrate will be there where you get trace element. Some substrate will be there where you get vitamins, and then you will have certain amount of biomass. So all these components should have defined formula like glucose. So if you have defined formula for carbon source, suppose we are using glucose as carbon source, we get a defined formula. Suppose we are using ammonia as nitrogen source, we get a defined formula. Suppose we are using P2O5 as phosphorus source, then we'll get a defined formula. Similarly, for trace metals, if we are using zinc oxide, magnesium oxide, calcium carbonate, so actually we can get the defined formula of all components. Similarly, for vitamins, suppose we are using B12, vitamin K, vitamin E, different kind of vitamins, and if you know the molecular formula of the vitamins, then everything is defined then. And finally, we need to also know the molecular formula of the biomass. So we can say that, yes, molecular formula of biomass is also known. So we can get all component present in the left hand side of the equation are defined. Now we need to check the right hand side component. So same biomass we are getting in the right hand side. So we know that this formula is defined. Suppose we are producing ethanol. So we know the formula of the byproduct. We know the formula of carbon dioxide, water or methane. So if in your stoichiometric equation all parameters are defined, then you can balance the equation and then calculate how much amount of individual raw materials are required to produce certain amount of byproduct. So this balancing equations you have already done in your class 8 level standard of chemistry, right? So if I just ask you to do a simple balancing of stoichiometric equation, then find out the parameters, then you can easily do that, right? Only thing is all the components should have defined molecular formula. Then you can easily do it, right? Because you can do elemental balance, like you can just check amount of carbon in left hand side and right hand side and then match them, and then you can find out the stoichiometric coefficient of individual parameters or individual component. So this balanced stoichiometric equation is very much important for estimating requirement of raw material for production of certain amount of product. Is it clear to everybody?
Yes, sir. Yes, sir.
Okay. So I'll stop here today, and the next class we'll discuss about more in this equations and stoichiometric equation, and also some model microbes with their defined formula, and then we'll also show you how to calculate the exact molecular weight of biomass and also calculate the trace nutrient content in biomass. So we'll have this class every Tuesday and Friday. And whenever we'll go for presentation, that time we will see whether we need to make any changes in the schedule. Anyone has any question?
No, sir.
Particularly two students I know, they are not from DBEB. So my request is to check the prerequisite of the course, because in course of studies, you will find the prerequisite. Maybe ERP will not be able to capture it, but if the prerequisite doesn't allow you to take this course, then you have to drop this course, because at the end of the semester, maybe the same ERP may not allow you to take this course as your open elective. So those who are from other branches, just make sure that you are allowed to take this course. And if you are applying for a minor degree in biochemical engineering, then definitely you need to take certain recommended courses. And if it is within that category, then you are welcome. But please make sure that you are checking the courses of study and following that prerequisite for this particular course. Otherwise, at the end of the semester, they will actually not give you due credit. So within first week, this add drop period, you will have sufficient option to choose the courses. So the students, those who are from other department, please make sure you are well versed with the prerequisite. And if you are meeting the prerequisite, you are welcome to the class. Okay. So stay safe. I'll see you again on Friday.
Yes, sir.
Yes.
Thank you,
Thank
sir.
you. Good afternoon, sir.
Thank you.
Sir, one thing is that if you can please share this a whiteboard with us, PDF of or image of this whiteboard with us, that will be.
I'm not sure whether MS Team has that facility. MS Team will actually allow you to record the video. So if you want to see the video, you can see that. So immediately after the class, it will automatically save the video in the same channel. So you can download the video and see it, but I am not sure whether it will be able to convert the video to any PDF file.
No, sir, this whiteboard, just this whiteboard.
Asha, whiteboard. Okay, I'll just save it as a PDF and then upload it. No problem. Sure, sure.
Yes, sir. Yes, sir. Thank you, sir.
Okay, thank you. Bye. Bye.